And welcome back, everybody. Come on. Oh god, I'm missing. And there we go. Yeah, welcome back, everybody. Sorry about that. I was gone for a while. Probably should have posted something in announcements. Yeah, that's my bad. Well, is that loud? Okay, no, it's just loud in my ears. Yeah, last week I was just too busy to stream. And this week it was less busy, so I probably could have streamed Friday or Saturday. But I was exhausted, and it wouldn't have been entertaining. But we're back now. Yeah, like, I keep saying this. I think I say this literally every time. But, I'm trying to stream more regularly, but yeah, at the end of the day, I have to get, school stuff done first, and I have to, at least pretend to take care of myself first before I can thinking about doing hobbies and streams and stuff, right? It is what it is. It's unfortunate. I don't like it, but I would much rather just be able to, stream all the time. More stream is more good. I enjoy it. I enjoy hanging out with y'all. Talking about shit, whatever the fuck we're talking about. Yeah. It's been so long, I don't even know where we left off last time. I mean, I'm looking at it. Here, let me just switch that. Might as well. Yeah, I'm looking at it. I have no idea what the fuck I was doing. I think... Yeah, we were working on this shit, and I was getting very confused on how to do it. I think I remember some of it. Okay. We're gonna do something smart, and we're gonna just think everything through in a file somewhere. Expr parse.md. Cool. So there's a couple of different ways we could do it. We have, right, we're looking at this, and I think there's, the way that I was trying to do it, the tree, or the parse tree, and there's obviously the reverse Polish notation. I think I didn't want to do shunting out because I thought shunting out is the thing that'll turn like an expression into reverse Polish notation. It's also called postfix notation. It looks like this. Now I have 2, 4, plus 3, and then a times. And you read it from right to left. So you see this, and you're like, okay, well, we're going to do times first. Or we're going to do times. Then you see the 3. Okay, that's the first operator of the times. And then you see the plus, and you're like, okay. Well, that's the second chunk. That's the second operand, I think is the word for it. Operand. Yeah. So the plus is a second operand. But plus is a function. Or it's another operator. So we look at plus, and we're like, okay, well, 4 and 2. So we do the plus with 4 and 2, 6, 6, and then 3, and we get 18. That's how you would read it, like, as a person. What a computer would do is it's like, okay, well, you have the 2. Great. And we have the 4. And then we see a plus, So we put these on, was I talking about stacks? I think I was looking at stacks here. Maybe. Yeah. So I have it here. So you have the output and you have the operator stack. This is also a stack. We call them, like, it looks like a list, because it is a list, but they're called stacks because you put something on top of the stack, and then when you want to pull something off the stack, you pull the thing from the top of the stack. So it's like, you know, a stack. Wow, who would have thunk? So a computer looks at this, it sees the 2 first, it adds that to the output stack. It sees the 4 next, it adds that to the output stack. And then it sees the plus, and it's like, okay, well, I have to do something with the plus. So it adds that, so it looks at the plus, and it's like, okay, cool. Let me pull the last 2 things off of the operator stack, or off of the output stack, and then I'll do a plus with those. So it pulls the 4 off, and then it pulls the 2 off, and then it does plus. Great, you get 6. And it puts that back on the output stack. Then it sees the 3, it puts that on the output stack, and then it sees the times, it pulls these 2 off of the output stack, does times, puts that on the output stack. You get an 18. That's your result. So that's how a computer looks at reverse Polish notation to do stuff. But for example, I could say that this is also now 3, 2, and then minus. And now this times, and then, okay, so you have this one, right? We're back here. We did the plus, so we put the 6 on the stack. Then we see the 3, so we put the 3 on the stack. Then we see the 2, we put the 2 on the stack, and then we see the minus. So we pull the 3 and the 2 off the stack, we do the minus, you get 1, and then we see the times, and we pull these 2 off the stack, we do the times, we get 6, and then there's your result. Basically, the other type of notation is called infix notation. There's a couple. There's prefix, postfix, and infix. Infix is what most people use. Right, 3 times 2 plus 4. But that's a pain, because then you have to look at, you know, which operators come first. Well, yeah, it's 3 plus 2 times 3. You see the plus first, but the plus doesn't happen first. You have to do the times first. Postfix notation says, fuck it. You see the thing first, you do the thing. So it's simple. Prefix notation is the same effect. You have to work with it a little differently. You would read that same way, except you would put things on the, you put operators on, right? You would put operators on the output stack, or on their operator stack, and then when you have 2 things in your output stack, you do the top operator, you put that on the output stack. So it works a little differently. It's a little worse for computers to use. Anyways, that's reverse Polish notation. It is the thing that's used everywhere, because it's just better. Obviously, I really did want to do the parse tree, because I thought it would be cool. But I don't know if it's cool or if it's just bullshit. So, and the thing with, you know, because what I thought about, I was thinking about, like, doing this, I was like, well, I mean, when you do this, when you do the shunting yard algorithm, which is the thing that turns infix into postfix, well, obviously that is something you do and then you evaluate it immediately. No, you don't have to at all. You can just kind of hold on to that and then evaluate it later whenever you need to. So that was dumb. Because that was probably, I think that was the only reason I didn't want to do shunting yard. Which is dumb, because it works. It works really well. So have we restarted this expression parsing probably like 4 times? Yes. Are we gonna restart it again? Yes. I should comment more. Fuck. I don't know what auto push was supposed to do. Okay. We did the lexing. We have all of these things. Do we use this at all? No, I don't think so. We'll see. Parse statements. Right, the other goal for the language is that it was... right, this is the one. Is that it didn't matter whether there were lines between statements. So you could theoretically do everything in one line. That was the goal, I think. I think I need to stop with the scope creep, I think is what happened. Let's think. So we have index less than end. If the token is a logic keyword, then we have to do stuff with it. Unless unless we do it like this, just everything needs to have a what's it called? A colon after it. Every type of statement needs to have a colon after it. That would help make things easier. Except for maybe a comment. No, even a comment. So just everything together should have a that. That would make that would help a lot, actually. Okay. So either it's a logic statement, and so then that gets caught by logic keywords, Yes, and then we're doing index. Yeah, we're doing an index because then we can shift the index along within a statement. Um, this one returns an index. I should really just get over it and comment. And index of closing. Wait, never mind. That's why we can do this, because either it's a logic, and then if it's a logic, we don't need to worry about this. Otherwise, we do. This is stuff we'll just add later. Right, just math. Return index of closing item. Now this should be underneath this. To look through closer. Doing that. How do you fuck? Start. Zero. And we say if it's a modifier none. Right. Because we don't know if it's a valid expression. That's where all of a lot of these issues come from. Because if we know it's a valid expression, parsing it is incredibly simple. If we don't know it's valid, parsing it becomes a little harder. What I'm trying to find is if it's this hard, it really shouldn't be. What do we get? Okay. What? Val is... Okay. Try call or unused else error. Tokens is how? It is token context unless value symbols is just all of this stuff that is reserved. Okay. Tokens.append is here, and this token should be like that. Lex value. Lex number. And then otherwise it's a and there, do that. You don't use context, but it's there. And where do we have for our return keywords? There, found it. Var. lowercase e? Or do we want to do uppercase e? I think lowercase e is... Yeah, we'll do lowercase e. We can change that later if we need to. If it's an e float, then we set that, and we move on. If this, so if it's a number, if it's a dot, then if we're not a float yet, then we can, change it. And now it's a float. Okay, yeah. Or no, I know this is just a float. Wait. Nope, stop. Where are we? Here. Dot in else wait. Wait, no, not a float. This is an int. Var it's and then it's tip. There we go. If one var greater than 0, this plus equals 0 plus that. If next of int equals space, or we don't need to check for /r. Var plus 0. Type, and then it's fine. Wait, no, actually, that doesn't work for this one. Where's the return? Return one line only? Okay. Cool. number does it now. All of our return statements come with a type. Good. When we're grabbing a literal, it also does that. So that's value. This one is a symbol. That one is also a symbol. And this one is something. And we'll do this like this. 0. Token of 1. Like that. Yeah, something like that. Cool. We should also comment this. Tokens. I capitalize these. Yes. Not consistently. Next. List of tokens. Raises. If the text is no. Just what's it called? It checks the text to be lexed, and index to start looking, lexing at, yeah, context, and the lexer, return the value text, the index that it's ended. Index after it ended. Raises value or lexers. If text start value new one. Now, that's fine. Start vehicle. Text to be lexed. Lexes are lexing at. The context from the main lexer. The context from the main lexer. The index after it ended, right? This, nope. Attempts to lex even text as a number, only one space. Should be start out number. Next, the text lexed. The index to start lexing at. The context from the main lexer. And you don't raise anything. Return number. Value of this type. Int float. Index after it ended. Raises your if the that's why then we do this. Error t dot make syntax error. Context line. What did we expect? Or underscore digit alphabetic alpha character did alpha character or for not raises. This raises the keyword. Qt dot make syntax error, text line none. Huh? Expected. Yeah, wait, no. Yeah, you just don't raise anything because we just automatically expect that to be true. And that's why we're going to set this to this, that. Yeah, you don't raise anything, that's fine. Value error. If equal to float, and type is not equal to e float. You'll just remove these, because then that means it's time to end. And type not equal to e float. Oh wait, nope, not type. Not in float. In float. float. Not equal to e float. Yes. Separate that. And go. There we go. Zero. Plus equals 1. It is 1 for e float. Number. Does it raise? It doesn't raise anything. And then we do this one. This one looks like that. Cool. Attempt selects the given text as a string. And what does this look like? String. One expects from text to be start of a string. The text to be lexed. The index to start lexing at. The context from the main lexer. Return. Yes. This would be valid then. This is an error that would make sense. This an error that makes sense. Yes, an invalid escape sequence. So never mind. You do also value. String parser error. Turns the, what did we call it? It was number value that was lexed. The string value that was lexed, its type. No, its type is just string. That's the actual return value. Index after ended. What else? We have this, and then it raises what? Raises what? Nope, none of this bullshit. If gets to end of gets newline before end of string if finds nice escape sequence. There we go. So that is this one. Now all of these have, oh fuck, okay, we'll see. This, I barely know what it does. I'm using tokens to into valid statements into parse. Into valid statements. The list. What did I do first one? It is list of tokens. For uniformity's sake, we'll do it like this. Value is next. After it ended. Token, I think that's how that works. Maybe. This likes value. This. I think even though it isn't like the most productive right now in the long run, especially because I'm working on this over a whole lot of days, and it'll be easier if I can just see the documentation that I wrote rather than trying to figure out where the fuck I left off. It's something it's not just here, it's something I need to get better at in general, writing comments and stuff for code. So that it's easier. When I was younger, I used to think that, writing comments for code, you obviously write comments for code that other people are going to see, but if no one else is going to see it, why write comments? Because especially back then, I was writing smaller programs, and my memory was also better. I was writing smaller programs, but also I was working on them more. I was working on them like a lot. So I didn't need to write comments to know what I was doing, because I did it like yesterday for like 3 hours, and it was great. I was having a lot of fun, and I thought, well, writing comments just takes time. I could use that time to work on it some more. But as I've gotten older, that's not practical at all. Even if you're writing code for just yourself, just something you're building because you felt like it, writing comments is still absolutely necessary. Also, if you write comments, then you get to kind of oh shit, yeah, like number can't actually get an E as its first value. Should be able to get a dot as its first value, but not an E. So this is just this way. Yeah, cool. No, actually, that's just bad. I was saying, yeah, when you're writing code, even if it's just for yourself, being able to see what you were thinking then also helps you make less mistakes, because you kind of saw the thought process then, so you can pick up from that trail a lot easier than trying to refine what you were thinking. And also now it's a new day, so maybe you have new ideas. Just because you have new ideas doesn't mean these new ideas are better than the old ideas. Token. What's it called? And even if it is better, it doesn't mean you want to restart the entire thing just because you had a new good idea. I don't know. I assume that if I don't remember what I was doing a week ago, anybody who was watching that also probably doesn't remember it too well. Obviously, that makes sense. I'm the one doing the programming. So if anybody's remembering it, it should be me. But I don't know if you are, or if you watch some of the VODs. You've probably seen this happen, where I'll start something one day and be like, alright, we're gonna pick up on this next stream or something. And then next stream, I look at that and be like, this is worthless. Like that. And then restart. That's not a good way to do programming. But yeah, you live and learn. I just haven't been prioritizing comments and documentation enough. Oh, right. Yeah. If this is a dot to nowhere, then we add a 0, otherwise we just roll it back. If this is a dot... if there's an E at the end, though, then E could be, I don't know, some variable, so we don't want to leave that right there. Oh shit, yeah. Something with this is that if it's minus, elif text. Alright, this is why. Because then you can catch mistakes if you actually go and look through it and type only if this is a float. Type equals int. That's dumb. Yeah. Type equals float. var plus equals text int. Var of -1 equals e. Then we can add the minus sign in. Number. Scientific. Get started X. There we go. Var of -1 equals this. If -2 -2. One of the symbols was the exponent symbol, right? Do we make that times like it is in every other language? I'll leave that as the exponent, because I think that's what's most useful. If that var of -2 turn -2 floats. Wait, nope, int -2. -2. Summarize promise we're gonna light it up. Actually, do we even want to? Yeah, no, keeping the, what's it called? The scientific numbers, like, together as one thing is probably better. Because, I was thinking of another way I could handle scientific numbers is if you see the E, you say, okay, yeah, text wherever this is, everything after that, but you replace the E with an exponent, and you could handle it like that. That would be the easy way to handle it, but I think keeping scientific numbers together is definitely more correct, I guess. Inside my own world of make-believe, kids screaming in their cradles, profanities. I see the world through ice covered in pink and cream. Watch out the world will watch me pour and watch me weep. Right, yeah, and then if we see, so if we see like the negative and we also just did the scientific number, so we tacked it on, we're like, okay, great, that's cool, but then it's the end. Like what we were doing here is, right, if we see a decimal point at the end of a number, right, so it's a float or something. Float is floating point. It's a, I assume it's programming term more than anything. Floating point just means it's a decimal number. And then I call this E float because it's a floating point with an E in it. But these are scientific numbers. That was just the first thing that came to mind. Right. So if we have a decimal and we see the dot at the end, then we say, okay, well, if the next character is a space or a new line or something like that, then we assume it's supposed to be a decimal with a dot 0 at the end. So we say, alright, well, it's a float, and we add a 0 at the end. Otherwise, we say, well, that dot is an operator then, not an actual, right, it's, right, this operator, and not a number. So, or not part of the number. So we just go back one, right, this is what that means. We remove the last value, and then we also set index back by 1, because we need to go re-look at that again later, back when we go and start parsing more things. Then we need to see it again. Obviously we don't want to remove it entirely, that would be bad. Same thing, if we see an E at the end, though a little different. If we see an E at the end, then then we assume that it's supposed to be some kind of variable, or the start of some kind of variable, rather than part of the actual number. So it doesn't matter. So we always roll back one, right? But if there's a decimal in there, then we need to say, yeah, it's a float, otherwise it's an int. Int is integer. Yeah. So we roll back one, we say, well, yeah, if we do, alright, this new thing, it's either a float or an int, because it doesn't have an E anymore. And so if there's a decimal in there, well then it's a float, and if there isn't, then it's an integer. And then same thing here, we roll back int by 1. Now here, it's a little different. Actually, I think this should just go at the end. Yeah, this should just be a break. And then we'll put all of this out here. Yeah, that's smarter. Right, so if we see anything else that we don't recognize and or that's not part of the number, then we leave. That's break. So ignoring that. Now, continuing on here. Right, if we see that negative value as our last value, so we said, hey, yeah, it is a scientific value, and it does have a negative exponent then, or here, if it is a scientific value, and it was the start of the scientific value, so it's cool, we have a negative. But that turns out to not be true. It is not a negative exponent. We assume the negative stands on its own, so that's an operator, so we have to already roll back 1. But then also, we still have that e that we had, because that's what let the negative go there. So instead of rolling back 1, we roll back 2. And then we do the same thing as we did here. If there's a decimal point in that value, in that initial value, then it's a float, otherwise it's an integer. Same logic as before, but we roll back int by 2, we roll back variable by 2, and otherwise, if it's not any of these, it's just standard, so we return it like we normally would. I don't think we do anything like that here, and same thing here. Yeah, I don't think we do any of that here. Here, normally up here, right, you saw we return stuff at the end. Here we return stuff at the end because if we reach the end of our text, well, that's clearly the end of the chunk, so we just return that, we process it, see if it's valid, whatever, and then we return it. With the string, we can't do that because strings need to end. So if it gets to the end of the text without returning, something's actually wrong. So we have the syntax error. Then we have this is for unrecognized escape sequences. An escape sequence is something like this, right? New line. That's the new line escape sequence. That's the tab escape sequence. Things like that. I think I have a couple in here. What have I defined as escapable? Slashable here. Right? Backslash is the escape character. So if you want to actually use a backslash in your text, you have to escape the escape. Right? So backslash. That's a valid escape sequence. Obviously, I have to use it twice in both of these, so it doesn't look like it does anything. But this says, well, yeah, after you escaped, if you see a backslash, that is valid, and so instead, it is something that you replace with just a normal backslash, and then you unescape. If you see the N, then it's a new line. If you see a T, then it's the tab. If you see a quotation marks, then it's an escaped quotation mark. And then if you see a single asterisk, or not asterisks, what's it called? Single quotes, then you replace it with the single quotes. But anything else is not valid, and I have no idea what it is. So we raise an error, that's an invalid escape sequence. Right, that's what's up here. And then also, if it sees a new line before the end. You're not allowed to use new lines before the end. You have to end the string, and then you can use a new line, right? Because if you see the new line, then that's the end of the current section. And, well, there are some languages that, right, Python has these multi-line strings that work like this. And then I think there's probably a language, I can't think of it right now, that allows for, using new lines inside of the string. But no language I know does that, and I don't want to include that, because that just makes everything harder. So if you use new lines in the string, you should use the /n escape sequence. Right, we use this as it's called a, what? A doc quote? Doc string, yes. Technically that's not what it's for. It is just a string. But how Python handles something like if I do like hello on this line and I just don't use it, right? You just ignore it. Nothing happened. So, go away. And you just stop. You don't do anything with that. Same thing here. That's why it's used, because using a bunch of single line quotes would make everything very annoying. So we use the multi-line quotes as multi-line comments, because Python doesn't technically have support for multi-line comments. So it's like a what's it called? Not jerry-rigged. Whatever. It's just the way that you do things to kind of get around no multi-line comment. And, like, I think it probably started as, like, a non-standard thing. Now that's standard, which is why like, when I enter when I started this, and then pressed enter, it filled it in with all of these. Because now this is standard. This is a specific standardized documentation system. I think this is NumPy documentation. There's a couple of different standards. This is one of them. This is one of the more common ones I've seen. And so it fills them in because this is just how you do it now. Doing it any other way is bad, because it's harder to read. Anyways, that's your lesson on Python for today. Well, we'll see. Right, if this is a digit, number, string, so, value. This is number. Do we need to include stuff here? I know we put stuff here. And convert to correct type. And back to. Oh, why does it say? back one index and convert to correct type. To float or int. One index. Roll back two index. This should be if first. Go back. Index. I think that's the clearest. Back on index. So there we go. Negative like that, and I got operators 1p up and token. So roll back to x. Index. So those are our special cases, like that. Do we need to do anything like that with Lex var? I think this is very simple, so no. This, though, we do. Line before string end. Line before string end. Sequence. Of text. Quote. Next. Defaults. Do we have a default in here? Text before end of string. of ind. I know, text, we are past. Wait, how do we leave? Is there a break in here? No. So this is just... Great guts. Does oh yeah. Okay, that's fine. End of inputs. End of line. Spell it out. That's fine. Do we use the abbreviation anywhere else? L? No. I? No. Okay, cool. Oh, parse error, yeah. So this should be a parse error. Parse error. There is no guts. Oh, right, we need one of those. Cool. Do we need any more comments? I think it's commented enough. String. Alright, I need to go to the bathroom. I will be right back. Turn up the music some. Hopefully it's not too loud. I will see you all in a bit. Alright, and we're back. Yeah, no, it doesn't return anything. It'll return something soon. Anyways, we were looking through that. Why were we looking through that? Oh, right, yeah. Right. Index, text, context. Some tokens. Is this one I think that we didn't get to? Yeah. Text. Just index. Less words is good. So we just kind of remove all of this. I think it's really better if I just do this. Uses so that goes in its own separate section. You don't raise anything on purpose. You also don't, but you do. So we'll split it up like this. Raises. Unrecognize escape sequence. There we go. That should be fine. And we did index, context, string value that was like cool. List, two parts. Words, two. Keywords to treat, especially. Term, parse statements. Right. List of parse statements. There. Okay. Statement end. So we find the end of the statement, then we do this like we did before. Cool. Do I need to comment on any? No, it's like 5 lines. tokens into statements. With start and end. Tokens to parse. Context from main lexer, yes, but from main parser. Index to start parsing at. And index to end parsing at. Optional. End of tokens. Optional 0. Yes. List of parsed statements. Yes. Of 1. String of 1. In floats. Parse types. We got numeric. Numeric types. Int float. Float. Right, I completely forgot about Boolean values. I guess Boolean could just be like, no, because it can't just be treated like a normal variable. Okay, well, I mean, we can probably handle that later. pt dot numeric types. Parse types, yes. Boolean value. Bool vals equals true, false, non-vals equals none. None? Or do we use null? No. K dot vowels. Return var pool. Null vowels and context line. Wait, what? No. Just like everything else. Infloat, efloat. And else, if one was full pass to do then try call or unused else error, same as once if val one equals null. So if it's a null type, then we same stuff. Do null try call or unused else error. If val of 0 equals if it's unused, then I guess we can just pass it, I think. Ignore. What? There we go. When it does that, it shows up green on this like sidebar, so it shows me where I've said, yeah, I want to look at that again, or do it again, as the case may be. Logic statements. Yes. Okay. we call it val? Just leave it as token. What? No. Token. Wow. And then just delete that. Item type. Oh, this is why. I think for all of these even. Is at the top. Yeah, if we're rewriting the expression parsing, we might as well also just entirely remake this. Do we use this anywhere? We hand it to X3. Okay, fine. And then we're just gonna rewrite this anyways, because this is actually just dumb. I don't know why I did all of this. Yeah. Modifier. Is this the property notation comes first? Yes. I mean, I guess we don't really need to. Even after bool comes the sign. -1. And a sign will go at -2 because, yeah, it's a update. Does update go up here? No. Modifiers are, no, that's a modifier, not an update. Or we do it like in order, just as like a list. So this would be, we put up here the sign symbols, and update goes at the very end. No, update happens immediately. Goes right under modifier, right under modifier. Update symbols. And these are your Boolean operations, which are comparison symbols, I think. Bool modifier and math modifier go together. Oh no, we're talking about bool operator. So the and or. Do we need any other one? Was it Zor? How is Zor represented? Zor operator. Zor is the one I'm thinking of, right? It's either this one, yeah, exclusive or operator in pi. Oh, it's from a separate. Oh no, it is this one. Zor basic bool operators. Yeah, I know. Give me, what are the ones that I need? So there's not, and, or. I think these are the only ones that we need. So and, or, not. Zor. This is just not, or. Have a more operator. What is? I'm pulling most of these from Python. Yeah, I know. Built-in Zor operator. And what the fuck would oh, NAND. False if false only if both inputs are true. Wait, what? Yeah, that's just, wait. That's, so this is not and, this is not or, that's fine. Returns true if both inputs are the same. Oh, that, yeah, that one would be annoying. So, Zor and then, Snor? No, I don't think so. Snor, that, well, wait. Oh, wait, no, this would just be not Zor. Because Zor returns true if the inputs are unequal. And Snor returns true if both the inputs are equal. So this would just be not. Okay, so yeah. And that is why we use the caret for these operations. I guess it probably wouldn't be too bad to say what. There's a couple others that we could probably implement by just doing like variations of the and or operator. Oh shit, I forgot to turn the music down. Sorry about that. What is this? Yeah, we'll just go back to yeah. Boolean operators. I know Python probably only has, because even Zor, the reason like you don't see Zor a lot is that Zor you can implement with just and or. You only need and or. But Zor is a pain. You say Zor is what? It is A or B and not A and B. This is how you would implement Zor with just the basic operators. So I do know a lot of languages do XOR, because that's a pain. Wait, no, this is either A is true or B is true. If both are true, then this is true. If both are true, then this is true, and so false. If both are false, then this is false. But if one is true and one is false, then this works, right? That's what XOR does. That's big. Nobody wants that. So a lot of them, like with Python, you have the caret for the XOR operation. Boolean operators. Just show me the Boolean algebra table. And yes, I know. What's the big one? That's not what I'm looking for. What? Okay. No. Jesus Christ. Where's the table? For examples used in text supported by Google. Search term 1. To a single search term. White space is used to specify a logical AND as its default operator. The OR keyword is used for logical OR, and then the minus is logical NOT. Oh, I didn't know this. Hey. See, we're educational. You learn something. So... Right, so if you put quotes, it makes it one search term. Yeah, I think that one, I think most people know. But using OR in all uppercase specifies logical OR in the search engine. And then using a minus sign specifies logical NOT. Huh. Fun. But that's not what I'm looking for. Boolean operator table. What the fuck? There. What the hell? And this. Okay. So if A is true and B is false, the implied get, I think, is the opposite. If A is true, okay, so if A is false, it returns true, and if A is true and B is true, it returns, what the fuck? So, okay, so yeah, that's just the opposite of the non-imply is just the opposite of this. Just cool, I think. So not this and B. So that's true. Oh, that's an OR. V is OR. Again. Not what I'm looking for, but a little bit. Which standard? Maybe this is helpful. Wait, what? Binary, logical, and... Oh. Oh, okay. Wait. Yeah, this is for conditions and this is for bits. Okay. That makes sense. Output. Wait, what? Oh. And always evaluates both. Oh, that's actually smart. Yeah, I mean, that makes sense. We might just do that. And just, or like that. What the fuck did I think this was gonna be? Oh, and equals or equals. Yes, I remember this. This is mod equals, divide by equals, times minus plus, and then just normal standard equals. Multiplication, add symbols, math is the, oh. And this one, we're missing one. This is divide mod, and then wait, how would you? I mean, I guess we can probably do this equals, but how would you do the times equals? I guess you can't. But yeah, this is probably good enough. What will this do? Because and equals just takes the two, does the and then assigns it. I guess XOR equals would do the same. Takes the two, does the XOR, and then just assigns it automatically. Yeah, this increments a number by 1, this decrements a number by 1, and then this inverts the value. So if it's a number, it turns a positive value negative and a negative value positive. If it is a what's it called? If it's a Boolean value, it inverts the Boolean value. I think that's the only ones it would work for. Because you can't do anything with the other ones. Yeah. Cool. Great. So we have assign is the top. That should happen the very, very last. What happens next? Some languages do the update symbols. So these ones, if they go before the value, then they happen first, and if they go after the value, they happen after. So it'll evaluate the expression and then do the update, and if you put the updater before, then it'll update and then evaluate the expression. So for example, like if you have 2 plus x plus plus times 3 or something, I don't know. But it would look through that. It sees that the plus plus is after the x. So whatever the value of x is, let's say 1. 1 times 3 plus 2, 5. Otherwise, if it's plus plus x times 3, then it sees that the updater is before the x, it updates x. Again, so let's say x is 1. It's a plus plus, so it goes up by 1. And then it does the expression with that new value. Could I do that? Maybe. I think we're just going to have it default to happening before the expression. Yeah, you see the updater, it happens first, and then you see the... And then you do the rest of the expression. The Boolean logic stuff goes here. So bool, operators, symbols, and the comparison symbols, and the add symbols. Yeah. Mult symbols x symbols. This is bool modifier plus math modifier. Was bool modifier is this, math modifier is just the minus. These are the update symbols, and then this is the property, wait no, subset symbols. Def get precedence. Wait no, this is your L. I equals 0. I is less than precedence if L in precedence of I, return I, return, because then that's not a valid operator. Okay. Set precedence like that. Cool. Primitive is how to do this. I don't think we need any of this because we actually have the types with it. Yeah, so we don't need this one. Hopefully we didn't use that anywhere. Handler. Oh, right, this is the thing that does the math operations. I think we... ignore that. We don't use the handler because it doesn't make a lot of sense. So we will deal with this section later. Okay, organized like this. Okay, so these are all of our symbols. Wait. Yes. Right, we flatten all of them so we get our math symbols. Sign. Do we have any overlap? That would be bad. I don't think so. We have that, modifier, this. These are our Boolean stuff. It's Boolean, this is that. It's our subscript, which, okay, that's fine. We'll call that the function. Because that isn't an operator, that is, well, obviously that's not an operator. This is also not an operator, that's handled its own way. And these are update symbols, go up with the assign symbols, and then something like this. Okay, better organization. Hopefully that helps a tiny bit, maybe. Yeah, we're just gonna do that, but let's get a good basis first. Yeah, if it starts like that, then it's an expression. But if it is an expression, then it's fine. Just get precedence, and then there's def symbol special. Up. Nope, not shift. Up like that. The special is the, what's it called? The stack. Thanks. Oh. Assign symbols. This for dot as answer. Wait, no, it's as answer extra assigned x. As wait, nope. I didn't finish that. Stop it. As assign. Valuer matrix. Is it syntax error? Yes, it's a syntax error. Line context. Context of line. And then what? Context. Equal parsing. There we go. Syntax error is this. Puts end of line. Because obviously you can't see a new line character, so we have to replace it with the end of line. Space selected equals space if elif got equals space got space. Anyways, we can work on this later. Do syntax error is this. because expected is always the first one. We expected none. So we got what? Sign. Extra dot has a sign equals true. So we just tack that on there. What else? So assignment operators are special. Hi, Digi. How's it going? How have you been? When was the last time? I don't know, like a couple of months ago. It goes. How about me? I'm doing alright. Busy, but we're getting to the end of the quarter, so it's probably a little more. It's more work and stuff than usual, but it's not horrible. Yeah, we're just. I don't know if you were here when we started working on this. It was a while ago, but I don't know if it was that long ago. Yeah, it is a plus. It did. We don't get a huge break, but we get like a week between quarters, so I'll take that. Yeah, so we're working on a programming language because I hate myself. It's an interesting project. Yeah, Digi, you're the one who does, like, you do rock climbing and stuff, I think, right? Memory. Have you done any, like, cool, what are they called, like, climbs? Have you climbed any cool rocks recently? In the last several months, you say you've progressed a lot. You're doing much harder routes. Nice, nice. I hope those have been fun. I don't know too much about rock climbing. I did it. Okay, I would say I did it a little bit, but I didn't really do very much. I think when I was really young, we had this this park with like a small rock climb next in it. And I did that, and I liked that. But I never really got into actually doing like hard climbs. It was like a couple of feet tall. I don't know, maybe like 10 feet total. So very small, just kind of like a kid-friendly rock climb. But I don't know. I don't think that counts. Yeah, I'm glad to hear that you're that the rock climbs have been fun. You know, progressing always feels good. That you're actually like doing more now. It's like the satisfaction that you put a lot of work into something and it's actually like paying off. Okay. You're doing routes under a certain skill level basically weekly, or it used to take you a month just to get one of the same level? Ooh, that's good. That's a lot of progress. So now you work on even harder routes from time to time? Nice. Yeah, just... Wait, I said this already. Fuck. Yeah, no, progressing it feels nice. Aw, thank you for the sub, Dino. 3 months? Wow. Shit, it's been a while. Dino, you can't hear you. You can't hear me, but you're still out, but happy 3 months? Yeah. 3 months is a long time. Jesus. You want to at least pop by and share that? Boop. Thank you for the sub. Where? How? Let's see. Oh. Yeah. I can type. I don't think that counted as a message. I actually have to check. I'll put that something as I need to check later. What was it? This is the 2:37 mark. Oh wait, no. 4, 3, check if Wait, Digi strength is still a big factor you need to work on? Yeah. I know strength's a big part of it, but also just the skill to kind of look at a rock and see, yeah, I can climb that. If I put my foot here and put the hand here, that itself is just, it's a big skill. Did you miss Nyx? Yeah. It's unfortunate she doesn't stream as much now. Hope stuff is going good for her though. Wait. We do this one. I know. Oh shit! What was the thing? Yes, we were gonna do stuff here. This was gonna be just Val's token because we don't want to change the token that's up here. This is just never used. Okay, yeah. That's what it is. We don't want to overwrite token though, because that would be bad. Actually, would it? Do we need to keep this around? Maybe. We'll see. Oh, did you? Shit, you had me on mute by accident? Oh, I think what I said here. I said strength, yeah, strength is part of it, definitely. I've heard that it's, obviously, if you're stronger, you can pull yourself up rocks more. You know, just the skill of being able to see a rock and plan a route around it is also really big. And, you know, if you can plan a route where you don't have to do big, like, pulls or, you know, pushing yourself up huge ledges, I would assume that's probably better to an extent. But yeah, and then also I said, yeah, it's unfortunate that Nyx doesn't stream as much. Do we just want to loop through this until statement end? Yeah, probably. Expert. Wait, no. Builder equals X builder. Wait, from where? That. Oh, okay, it is from there. Export tree. I was worried that it tried to import that from who knows where. It does that sometimes. It's like, yeah, you wanted. It's like, hey, yeah, you wanted this? Well, we know where that is. It's in this random fucking package all the way over here. It's like, nope, that's not what I wanted. It was just, I put it there because I was gonna, deal with that later. Where's it? Up here. Yeah, I think we just convert it to a reverse Polish expectation. And we did the same thing again. If this is what did you? It's taking you 2 years to get where you're at now. Yeah. Progress. Progress takes time. I'm sure you already know that. Sometimes I know. I notice this for myself. Obviously, I don't know what's going on in other people's brains, but at least me, sometimes when you like start working on a skill and then you get to a certain point where you're like, oh, hey, I kind of know this. I get this. I can do this. And then, because you've reached that kind of like, just as you're getting out of the beginner stage, and then you feel like you kind of get it. Maybe, like, even if you aren't, like, super overconfident, you feel pretty good that, hey, yeah, this is cool, and then you reach something that's just way harder, and all of that kind of self-confidence plummets. It's actually happened probably like 3 times with coding. For me. Yeah, I think the first one was when I started learning Python, and I was like, oh, okay, I get it. This makes sense. I can do this. And then I got to the point where I started using like libraries and stuff and working with the much more complicated aspects of. Well, I was learning Python as I was learning just how to program as like the skill in general, and I thought I got it, and then I didn't got it when I started actually trying to do complicated things. Thank you for the hydrate, Digi. And then when I started to do some really hard, not really hard, it was intermediate stuff maybe, and I was like, oh, no, I don't know shit. Oop. Okay. Yeah, I know. Nope. Stop. Go away. Yes. Yes, that is the goal. Right now we want to convert it to postfix. What was I saying? Yeah, I started to do like basic, like intermediate, beginner intermediate kind of stuff, and everything that I knew, it didn't go out the window, obviously, all of that's still relevant. But I felt stupid again. Because nothing made sense at all. And then, as I got past that, and then I moved to the more complicated languages, I think C++. Very similar thing happened. Nothing made sense anymore. It's like, I knew how to program, and some of that still applies, but most of that just leaves. Because, like, when, it's a good way to explain it. In C++, what happens is that you are working with, or like in Python, you have, like, the variables, right? Did you hear Hello Smart? I find that I'm good at explaining things, but when it comes down to it, I do think that I get, like, what's it called? Logical stuff, like math, science stuff, a lot easier than some other people that I know. And then there are some other people that are just not, like, not human at all in the slightest. That just doesn't make sense, but they can, and that's the shit that's really impressive. But I find that I'm just a lot better at explaining how I get through things. Yeah, that's what I was saying. Yes. Right, you have this object, right? This is a class. If you put the class, this is the initializer, or the constructor. Basically, I say, alright, you see this? This is an object that I want to work with. It has these methods, and I'm going to give you this thing into the constructor. You do whatever you want with it. I don't know. In this case, it just kind of stores it. But different constructors will do different things with it. For example, here, I think I explained a little bit of this once, but it calls, right? This says, hey, yeah, upnode, that's an object, or it's a class, so I can use it to make objects. It's like a blueprint. Upnode is a blueprint, but I don't want to, but upnode will have very similar behavior to regular node. So, we say, yeah, upnode is, I will take regular node and just change some things, or add a couple of things. But otherwise it's the same. I don't think we need any of this. Or we don't need this, at least. I might still use this, we'll see. No, I think we do need both, but I'll probably not store it as either of these. But so, because I told it that I have a blueprint, and this blueprint is just a modification on top of this blueprint, when I make an object, I use the blueprint to say, I don't know, build a house. I can't build a house. This doesn't tell me how to build a house. This tells me how to take a house that looks like this and make it look like this. So first, I have to go up here and build this house. That's what this does. It calls the constructor for this one. Now this one builds a house. And then after that, we do whatever modification we want. So these are how objects work in Python. In other languages, most of this is very similar. The difference is that when you're working with an object in Python, you are working with what's called a reference. A reference is like, right, it references the object. Wow. But it's like here, there's an object here, but I don't want to hold on to the data because moving a bunch of big blocks of data around is expensive. So here is where it is in the memory, You go find it yourself. That's what references do. In Python, everything is a reference. In Java, everything is a reference. In JavaScript, everything is a reference. So all the big programming languages that people would start with, everything is reference. In C++, you can use references, but things don't start out as references. Which is annoying, because a reference... okay. When I'm working with something, let's say a number, and I call a function, I say, I don't know, okay, not this one, it's a good... I have one in here, probably. I don't know. Okay, this is some string, right? The operator that I was worried about, and I want to get the precedence of it. This is a string. For the sake of this, we'll say that this is just a chunk of data. Strings are references, but they work as if they weren't. It's confusing. Languages just kind of decided that would be the best way to do it. But this is a chunk of data. I have, I don't know, some string, and when I pass it in, when I call this method and give it that string, instead of moving the string over to this new function, it copies it. So if I have a number, 2, and I copy it to this new function, nothing happened. It's still 2. It's fine. If I have a string and I copy it to this new function, the string still says the same thing. But if I have a big complex object like this, and I copy it over, it copies the entire thing. Which is why a lot of these languages work with references. Because if I say, yeah, I don't know, the object you're looking for, his address is over there, and I take that sheet of paper and I make a copy of it, it still points to the same place. It's great. C++, and I think C, both of them don't do that. If you want to make a reference or a pointer, you have to do that explicitly. And you have to do special things with those so that your program doesn't try to take up too much memory. All of that is very confusing if you come from a system that works like this, and you're like, why the fuck is my program taking 15 gigabytes of memory? Well, it's because you copied your huge object a whole bunch of times. And the reason they do it like that is that it is much more beneficial there are benefits to being able to work with the object's actual data instead of a reference, which is why they do it. It's just confusing when you come from this, and that system made me feel incredibly dumb again. I still don't have a good grasp on how that works, but I kind of understand it. Yes, I know we were looking at this. When we see a parentheses, what do we do? Okay. that makes sense. Hopefully I did a good job of explaining how that works. It's not relevant at all to what we're doing here. But it is definitely a thing that becomes very important. Did you hate to go, but you guys are doing chores and crap before the start of your Hell Week? Well, I'm sorry that your week is not gonna be good, I assume. Yeah, have a good time zone. I hope the week isn't too bad, and I hope you get your chores done quickly. Bye. Thank you for stopping by. I appreciate it. Kind of. We are going to rewrite this, I think, and then we're going to just completely remove that. Yeah, that. Not super happy about, undoing all of that work, but hopefully it works a little bit better. One, it's easier, and two, hopefully it works better if we do it this way. This one, this is add. I don't know what auto push was going to be, but we're going to remove it. We just of item of 2. Wait, 2? 1. 0 is value, 1 is type, I think. That'll work. If of 0 is not in pt.symbols, I think. Item in pt symbols. Obviously to do dot to do else, then we just self dot output dot append item. 0 in symbols. Then we get the precedence. if item of 0 in pt dot its export contain. Yeah, no, we're treating this one like a function, and that one shouldn't even be in there. Cool. If this pt dot export contain symbols of 0 self dot object dot container. So if symbols of 1, well, self dot and self dot op stack. Greater than 0 and self dot 0 is not, wait, not 0. Wait, no, it's -1, 0. Yes. I will be right back, chat. I need to go to the bathroom again. Right, music. You're not that high. Alright, be right back. And we are back. Desktop. One tab. Else. Where does pop happen? Pop happens at the end. Default is last. Yes. Self dot set dot append, which puts it on the end. Self dot. Make my dot. Remove? What does remove do? Remove is remove by value, if I remember. Yes. That's pop. Equals false. Popped equals this one, so we pop the last item. If popped item of 0, wait no, popped item 0 in dot, wait no, not symbols, it is pt dot x for continue, wait no, if this equals of 0 equals true, break. Otherwise, then we self append popped item. And we append the entire item. So we still have all of that extra, data and stuff. Well, I guess specifically the type, but the other stuff. If not found. Pt dot make where is it? Here, right? Make matter closer. If each end else make error parse line expected matching match error. Alright, that's why we don't need the context, because it's just up. It's just up of 0. Of 2. Welcome back from ads, everyone. Thank you so much for sticking around to help support the channel. Item of 2, what? Weeks opener. Okay. That is if we find that we have this one. If it's this one, else this equals self dot of item of 0. Yeah, okay. Item of 0. This spec is less than or greater than? Right, we start with the stuff that happens last at the top, right? So this would be the lowest. Self dot. Of 1 is symbol. Otherwise we just add it to the outputs. And then 0. Make parse error. Match error. Make match error. Opener is the these are just flipped. That little special. Self dot wait, self dot, I don't know, expert kind of yeah, expert stack equals this def adds to do implement. This would just be reading the postfix. This equals none. List none. is it? Store. This one. Is store equals x for store. What the hell? Yeah, I think we use. I don't think we even do this. It just doesn't accept the. Alright, for store.add item. pt dot handle special store item, right? This one is you handle the expression and the item, and dot has sign is false. And we still do this because does it? No, it makes it more confusing if we do it this way. So just do it like that. And self.has a sign. We'll handle that later. This is the one we're worried about now. This for logic. Oop. If and is equals index plus 1, nothing, we just pass. Parse expression tokens. What is in context anyways? Where is context used? This, yeah, no, this is dumb. We're gonna rewrite all of this, but we also don't need context because the line is stored with each token. builders, extra builder, looking for item, and yeah, that's fine. Okay, that's first do we check if we're looking for items and then do different things then? Yeah, I think we can use modified still, right? At least the idea of modified is fine. It just kind of stores. It's kind of like a function, because it's just one item, which is okay. No, no. Class modified. Do we? Oh yeah, I don't know why I did this. Okay, well, one more thing to handle later. To do like, actual errors. Exception classes. Modified, which is just def self. Actually, do we even need this? No. Modifiers are an expression, like the rest of these. What did we put in the up? So that takes 2, that takes 2, comparison takes 2, add multi-x takes 2. These only take 1. That also only takes 1. Subset takes 2, technically. An expression we expect to see. These things. Oh yeah, I was gonna add a modifier comes after update. Yes, because modifier works on the value. The subset comes before that. Okay. So how do we handle this though? Or do we just not use subset at all, and then if we see it, we pull it? Okay, the other thing I guess we can do is we can say at last equals none. Def move self pop. No, we don't need this. I think we'll. Do we need pop then? No. Okay. Never mind. Ignore that. No. RPT dot. Get precedence. It's a function. So do we even need this? No, we should just be using the pt dot get precedence. Dot get precedence. I guess we can do this again then. Token list equals none. If this is not none. Builder equals extra builder. Builder.build self. Self. Then we build it onto ourselves like that. Yeah. I'll use it. Okay. We'll probably have to end it here. Probably soon. So I'm gonna get this done real quick. Builds expression into postfix station. These are the ones we're working on. I don't want to remove it just yet. Right, so we'll just put that under it. To be removed. To be removed. Cool. This one. Did we change some stuff here? Not yet. Residence. Operator. Oh my god. It's 1P. I know. Operator. Lovely. Those metadata special /operators. Objects. Check. Return. It doesn't return anything. So nothing. This, we know what this one does. Cool. We do. With new expert filter and expert store. Revamp with that. There. I think revamp is the right word. Hopefully. Probably. Maybe. Okay. Parses. Tokens. Expressions. Tokens to parse. Context from main parser. I don't know why that's relevant. We might just remove it later. Index is set optional 0. End of tokens. And list of parsed expressions. No, just parsed expression. Oh yeah, there's a bunch of errors, but that's okay. We'll deal with those later. And it's next time's problem. Cool. Well, that is going to be it for today. Thank you all so much for watching. I really appreciate it. I know the schedule hasn't scheduled, but actually, I'm not going to promise anything. I don't know if I'm going to be able to stream regularly. Obviously, the goal always is to stream regularly. You know, I like this. I want to do more of it. But, and also, you know, it's nice that, you know, to do it on a standard schedule. But everything is a little fucky-wucky with the amount of stuff I have to do. So I'm not going to promise that I can. With that being said, I really appreciate it. Remember, take care of yourself. Dying is in fact bad for your health. Let's see if we can go raid someone. Yeah, sure. Yep, there you go. Raid. That's the raid message if you aren't subbed. Oh, there's both of them. I forget. First one is if you aren't subbed. Second one is if you are. Again, I appreciate you all. Take care of yourselves. Don't overwork yourselves. Drink water. Eat food. Rest as you can. I know sometimes it's hard. And I will see y'all next time. Bye.